Hi, these will be our basic derivative rules to find the derivative of a polynomial. So we're going to see the basic rules. We have first the derivative of a constant. If f of x is a constant, just a number, the derivative is 0. The derivative is the instantaneous rate of change. A constant function does not change, therefore its derivative is 0. Then we have the derivative of a power function. As we've seen in class, if we have that f of x is a power of x, x to the power of n, then its derivative, we bring the exponent down, n, times x to the power of, we subtract 1 from the exponent, that would be n times x to the power of n minus 1. For example, if f of x is x to the 5th power, then its derivative, f prime of x, the derivative is f prime, is 5x to the 4th power. These are two of the basic ones. Then we have the derivative of a constant times a function. If g of x is some constant number times a function f of x, then the derivative of g prime of x, is that same constant times the derivative of f. We'll see examples of this in a bit. Finally, we get the derivative of a sum or difference of functions. So if function g is the sum of functions f and h, f of x plus g plus h of x, then the derivative of function g is very simple. We just take the derivative of function f and we add it to the derivative of function h. And if it were a difference, f minus h, then we take the derivative of f and we subtract the derivative of h. So with these, we're going to get the derivative of polynomials. So in each case, we will find the derivative function. That is called to differentiate. We will differentiate this function. Notice here we have a sum of two power functions and 3 times the power function x to the 1. So the derivative, f prime of x, is, well, we apply the power rule. That is, bring the exponent down, 8, x to the power of 8 minus 1, which is 7. That's the derivative of this. We add it to the derivative of x to the 5th, which is 5x to the power of 4. And we added to 3 times the derivative of x. Okay, so that would be 3 times something. Well, let's see. X is the same as x to the power of 1. So its derivative would be 1. X to the power of 1 minus 1 is 0. But x, any number except 0 to the power of 0 is 1. So this is 1 times 1, which is 1. So this would be 3 times 1. Now you do not need to write 3 times 1. You just write the 3. So here would be 8x to the 7th plus 5x to the 4th plus 3. And that's the derivative. Another one. G prime of x, the derivative of g. Okay, now here we have 10 times the derivative of x to the 3rd, which is 3x squared. Then we subtract the derivative of x squared, which we bring the 2 down. X to the 2 minus 1 is 1. Of course, we won't need to write that 1 exponent in our final answer. Plus 6 times the derivative of x. As we saw, the derivative of x is 1. So 6 times 1. minus the derivative of 7. 7 is a constant. It doesn't change, so its derivative is 0. So our final answer is 10 times 3, that would be 30x squared minus 2x plus 6. Two more examples. Okay, this one's a little bit longer, but it's just all the same. It's a polynomial. So our derivative, the derivative of f prime of x, is, okay, 50 times the derivative of x to the 20th. That would be 20x to the 19th. Minus pi times the derivative of x to the 8th, which is, bring down the exponent, 8, x to the 8 minus 1 is 7, plus 6 times the derivative of x to the 4th, which is 4x cubed, minus 3 times the derivative of x, which as we know is 1, plus the derivative of 200, which is 0. And then we just simplify. This is 50 times 20, that's 1,000. X to the 19th. Pi times 8, usually we write up 8 first, so 8 pi, x to the 7th. 6 times 4 is 24. 24x cubed minus 3 plus 0, which we won't write. And that's our answer. Now, if the polynomial is not written in standard form, well, first we write it in standard form. Later we'll know rules to get these in a different way, but right now what we have to do is expand. Now you should know how to do the squaring of a binomial. Okay, this means 5x minus 3 times 5x minus 3. But in class, we've learned that this expands by squaring the first term. That would be 5x squared. And then multiplying the two terms times 2 also. So plus 2 times 5x times negative 3. And then squaring the second term, plus adding the square of the second term, negative 3 squared. So this is g of x still 25x squared. 2 times 5 times negative 3 is negative 30, minus 30x. And negative 3 quantity square is 9, plus 9. Now we're ready to get the derivative. G prime of x. Okay, 25 times the derivative of x squared, that's 2x to the 1, minus the derivative of 30 times x, that's 30 times 1, plus 0, which yields 25 times 2 is 50x minus 30. And that's our answer. I hope this helps.